inside Google. Google's infrastructure inside the network. They run all these servers, all these pods of racks of servers. There's no router in there. Inside Google. So on there, there's they'll run their pods, and you know what's at the top of rack? Is quad. Quad. it exists. One reason. You guys were not building good quality DNS resolvers. Right? So Google was looking at this 10 years ago and saying, this is nuts. Nobody's upgraded the DNS resolvers. It's impacted my business. So what's Google do? They deploy Google DNS. What's the whole function of Google DNS? To get something that works better. That's all Google DNS. Guess what? AKAMAI, we just did the same thing. I can point you to addresses. We actually got the infrastructure bigger than Google DNS now. All right? In the cloud. Okay? But what we're trying to do is where the best place to put DNS resolution is as close to your customer as possible. That's the best place to put it. Right? So that's why we got the software. Go ahead next. So let's rethink some of this. Go ahead next. So think of the DNS not just as a DNS resolver, but think of the DNS as something that can enable services. Because if it's the first thing I talk to, right, when I connect up to do a web page, that means it's the first thing I can actually do some sort of policy to and do some checking on, right? Like for instance, malware, right? Somebody's trying to send you a fish and try to break into this computer by sending you a piece of malware. Guess what? What's the thing that malware depends on? DNS. So if I am a security person and I know here are the bad DNSs that are being used for malware download, let's stop it at the DNS level. Right? So then on your computer, it can't even get the DNS says failed. Right? You just protected, so now you don't have a malware infection on the computer because you turned DNS into a security tool. Right? It took Paul Bixby and I some arm twisting to get David Milovich to say, okay, my OpenDNS project is going to be doing security. And he sold OpenDNS to Cisco for a lot of money for security, right? Because he turned the DNS resolver into a security tool. There's no reason why you can't do the same thing with your DNS resolver, right? You're already doing some of that now because the DNS resolver for you, you're already doing, parental protection service. It's called the government list, which is getting bigger, and bigger, and bigger, and bigger, and bigger. And one of the reasons why your DNS resolvers are getting slower and slower and slower, that's the list gets bigger and bigger and bigger. Okay? There's no stopping the size of that list. So this is another reason why you're looking at a modern DNS resolver is bind and unbound is just going to blow up. That happened already because of the list coming in. Even when you convert over to RPZ. Right? So yes, finally, agency has sent RPZ feeds out. Okay? So, but it's still going to run into a float because it's not designed for that. Right? So that's why we need to rethink DNS. Go ahead next. So just look through this. You can read this when you pull down the slides. But essentially what AnswerX is built on, it's the DevOps-oriented piece of code that goes on any common off-the-shelf server, works in the VM, works inside of the containers. Right? We don't have a fancy GUI. It's scripts. And it's scripts that allow you to configure to do many different things. You already have things you have to do on the resolver with the government ending. Right? But what if you tie that into your DHCP and your customer radius? You can do things like that. What if you started offering extra services on top of it? What if you could take the logs and use the logs for security and business intelligence? Right? So this is rethinking the DNS resolver where you can do many things with it. Go ahead next. Right? It's a modular approach. There are two major functions. The AnswerX engine, right, and then the reputation knowledge server, right? The reputation knowledge server is the thing that will take in your government list, put it into a table. The table scales to as much memory as you can take in, and we got some really big tables out there. So the tables we use for some of our security and parental controls are 7 million times bigger than the tables we get from the government. We know we can scale quite well. And we can pull multiple tables, right? So like we got somebody who's pulling in the spam house feeds, pulling the servo feed, pulling in our parental control feed, and pulling in a feed from our CSI database. You know, 4 different feeds and then pulling it into it, right? Then they have another government feed for law enforcement. So we know that the tables scale quite well. But then we also can pull in radius, UCP. If anybody here is from a mobile company, you know we integrate with CRF. So then I can say this person is a subscriber, and this person goes through filter 1, 2, and 3. This person is another subscriber, and he goes through filter 4, 5, and 6. And I script it, right? Because I can do subscriber preferences, all based off of lookup. Go ahead next. So this integration with your AAA is one of the key components in there in a modern resolver for a operator. Right? Go ahead next. Having a flexible scripting language is the next thing. You don't want to wait for a new feature. What you want is to be able to say, oh, I got a problem with my network. Let me code around it. Right? Don't call in the vendor, don't hope there's a new feature. Basically, what you want in today's modern network environment is where you go like, wow, okay, problem. Here's what's going on. If I write a little script and do this check, then my DNS problem goes away. And that's what APJII is built for, that level of the power of the scripting. All right? There are many times where I joke with one of my co-architects, they've got a script, and I say, hey, we need to write this feature. And his response is an email with a script. You know, and so instead of coding the feature, he says, no, I just script it this way and boom, you can do exactly the same thing without a new feature. But I'm always back and forth with my friend Robert Wyatt, back and forth of like, hey, we need this feature. IETF says we need this feature. Customer wants this. Boom, here's the script. Okay. How much load does it take? That doesn't take any load. Check A, do that, reformat, do this, done. Alright, so that's excellent. Next. So a scripting exercise would be like, oh, identify a new data feed. Like somebody comes to you, like the government says, okay, we're investigating a child pornography ring, right? And we need your help, and we need you to do a feed, right? So it's an emergency thing I got to do right now. You can't want time to talk to a vendor. You got to get it done right now. So take the new feed, enable it RPS, set up the table, set up the rule, define a policy, and away you go. In this case, if it's a law enforcement thing, it says, I want to log. I want to see everybody's going to these sites. Okay, now I got the subscriber database, identifying individuals going. Now I got the DNS wiretap. Set up that you can do a law enforcement yourself. All right? Go ahead, next. You can stack these policies up. Right? And it doesn't cost you when you need to do a new one. In other words, law enforcement comes in, it's 1 o'clock in the morning, you don't need to call somebody like a vendor for a license. You just configure it. That's what we want. We want that sort of flexibility, just to be able to fix it on your own power, your own knowledge. The role of a vendor like us is we can help you configure it properly. That's it. You don't have to pay for anything extra. Go ahead, next. So this is an example from UK. We have one of the big operators set up this logic flow. So they have rule 1, which is input security. Rule 2 is law enforcement. Here's a bunch of child pornography sites or an investigation going on, right? And so this is UK law, so understand this. Rule 3, they have a whole bunch of takedowns. We're doing malware takedowns of botnets. And we get these feeds into communities. So these are community feeds knocking down big botnet schemes, right? Then the next one is a whitelist. Do not blacklist Google. Do not blacklist Twitter. Right? Take the Alexa 5000. Don't blacklist the Alexa 5000. Right? So you put a whitelist in there. Then you take a third-party feed for a blacklist. So this makes sure the third-party feed doesn't blacklist the others. Go ahead next. Right? And then you get down to services. The one before that was a web protection service and a parental control service. So you can see you can nest through these services this way. Go ahead, next. You can also do what a lot of people go, oh, my customer goes to Google DNS. How am I supposed to put the rules in? Right? Now I know some of you do is you do port 53 redirect to your servers. That breaks things, and it makes your customers mad. Okay? Now what you would really want to do is proxy. Put the filters in place, but allow Google DNS to be Google DNS and Open DNS to be Open DNS. All right? We have this deployed now in a big carrier in the United States. Right? So you use APJII as a shim, right? Where if people went to 8888, you set up a rule, a rule to say, I'm going to run these policies. So it goes into it, I'm going to run my policies. Then I'm going to allow Google DNS to be the resolution engine. Right? Because we break the resolution engine. We either use the resolution engine in your server, or you say, for this profile, I'm going to let Google be the resolution engine. Now the user doesn't even know that there's something in between. Because they think they're going to Google. They think they're going to OpenDNS. But you have a policy in between, and they're scratching their head going, how come I'm still getting the government filter going? Right? Because the rule isn't. Right? That's modern DNS, where you can have and create those problems in there. I'm going to create solutions to the problems. Go ahead next. Right? And log it. Log it. Log it. I love data. We're going to be talking about data with the network portal next. AKAMAI loves data. So anything AKAMAI goes out there and buys, we got to make sure we can do massive data export. So you take the same ANSWER server, rack and stack the servers, and you configure it in analytics mode, the data export mode. Now I can go through and I can take PCAP streams off the ANSWER, or we're coding DNS tap. Like if you have a bind server with DNS tap, you can take that, and then you can ship it across your network, and then you can put it into different analytics tools. And then you can start seeing what's going on with DNS. And you can do what some of our customers do. They sell it. Right? So when you have, and especially this is my advice, anybody here from the government, any government people want to raise their hand? You know, maybe they don't want to raise their hand. But in the United States, some of the carriers, what they do is the government says, oh, you should give us DNS data. They go like, no. You can buy it. I'm carrying it. I make money. That is valuable. I'll anonymize the PI, the privacy information, so I'll anonymize the PI, and then here's a key. Right? The government says, okay, here's the check. And they sell it. Data is valuable. Data is a commodity. You have to protect your users' privacy, but there are tools out there. So one of the tools are going to be put in ANSWER 3.0 in the list. You know, it'll either be 3.0 or 4.0, depending on how much code we're going to do. But we're going to put an anonymizer in the analytics function. Right? So that way you don't have to buy a separate anonymizer. And you can just run one of the algorithms that is proven in the industry to anonymize, and then here, you know, government, you can buy a feed, here's the police, you can buy a feed, and then they'll have their tools. Right? And then now your DNS infrastructure is making money. Right? And when your DNS infrastructure is making money because you're building services and you're selling the data, guess what? Now you get funded to upgrade your DNS. If it doesn't make any money, if it sits there, there's no money. But if revenue is attached to a service, your network engineers, you know how it works. If revenue is attached, it gets upgraded. Right? Because they want to keep the revenue flowing. Right? We'll get it next. We are starting to sign up partners. So we got partners. Nominate is a DNS company. They run .uk. right? And they started taking their analytics tools and their offerings. So we plug into Navi, we plug into Deepfield. We're working with Farsight, right? So we have different DNS analytics companies that we're going to be partnering with that we can refer you to if you want to try these out. Go ahead next. The other thing is on the scripting part. There's a specification we wrote called the client ID. Now we're going through this Wi-Fi here in the room. Wi-Fi probably has the DNS proxy with this feature in there that allows you to send a MAC address up to the DNS resolver. It's a piece of experimental code in several of the DNS flavors in WRT. Okay? We use that for our services, but that was the experiment. And then OpenDNS had another thing they were using for DNS scripts, and then Nominum had something that they just started using Apple's specification. So what we did, we put it together, we created this thing called the client ID, right? And so this is something we're going to promote in the industry over the next year, and you guys will benefit from it because as we get it into WRT and other things, you'll be able to build services on it. And then you can use it to see what's going on inside the home. You turn it on in the CP in your house, and then all the IoT devices allows you to identify what's still going on there. Some people say, oh, privacy issue. But for a telco, you got to know what's going on your network. Right? So it's a valuable tool. And it allows you to do things like this. Go ahead, next one. Because you got all these IoT stuff going on. And as we learned with Mariah, what was Mariah? IoT TV cameras getting infected. You know, I read today on one of the security lists, there's a radiation detector monitor, IoT, and it's got a bug that allows bad guys to load Mariah onto it. And the manufacturer who built it decided they're not going to fix it. So here you have at nuclear reactor facilities, if they don't do their security right, then they're going to have the radiation monitors get infected and shut off. And now you have a physical health issue. If I walk into a room, right, and the radiation monitors start doing stuff, right? So, you know, that's why security in IoT is important. That's why visibility for is important. Go ahead, Matt. And then, of course, AKAMAI. How many people knew that AKAMAI is a security company too? We're a big security company. You know, anti-DDoS, security tools, protect the stuff, and we collect lots of data on all the security attacks. Because if you're counting your attacks on your network by how many attacks per second, you get a different perspective of what's going on with internet security. We turn that data into tools that we can then, you know, feed to you to help you build and protect your network. Right? So that's part of it. Go ahead. Next one. Now, how do we know AnswerX scales? We've got AnswerX, the software all in a whole bunch of big operators in the United States, big deployments, thousands of boxes out there. We also just finished a AnswerX cloud deployment. We got it deployed all over the internet, 53 different countries. You know, big deployment with it. And as soon as we started commissioning this, it was starting to get attacked. Right? And what are we using? Stack of Unix servers. I gave you guys the secret sauce how we're doing it. It's a stack of Unix servers. Right? Top of rack router, Ethernet switch, dividing half, a varying deployment. Right? That's how we're surviving. What we'll do is, if one of the regions get overloaded, it's a script, right? So we watch it and we go like, okay, let's pull this one off. It's horizontal scaling, right? So horizontal scale. If the attack is coming in here, we'll shut off the service. We'll have the service advertised from other locations. We'll allow the attack to come into that node, and we'll have our security guys who then work out on the internet and start working the attack. All right. So even though it's going towards that target, we're able to, like, you know, lock it down where it's going there, then we start working on other parts, and work the attack. So, and that's our cloud. So, in the whole thing, APIs, which we'll talk about with our network portal, because AKAMAI, if you are dealing anything with AKAMAI, ask for the API. We are big on APIs, right? Which we'll explain, I think the way to start this out, not so much on AngelX Cloud, but on the network portal with the APIs there. So we're going to be talking about that. So, in future DNS, one of the features of DNS is going to be where DNS becomes the second thing that happens on the network. So one of the things we're being asked to do is when you use WhatsApp, you're sitting here so I get to use you, right? As an example. When you use WhatsApp, okay, I do DNS first, then I do an encrypted session, right? So DNS, HTTP, TLS, right, into the API, okay? And anytime on the WhatsApp you see a lookup, it does the DNS out. DNS is out of WhatsApp. So if I wanted to watch you, like evil state security, national security agency, United States, right, is watching you, right? Michael Snowden, right? So and stuff, right? I can see the DNS queries. So even though they say WhatsApp is encrypted, it's not fully encrypted, right? So what these application vendors are thinking of is, okay, what if I just do HTTP anycast? I set up the crypto session, then I move the crypto session to the closest node, then I do DNS inside the crypto session. So instead of DNS on your network, DNS is in the cloud. And that's what people are thinking about. Can we do this? That's what this infrastructure is about. We set up the test infrastructure because these are our customers too, and they're asking us to do that. Now, if we do that, the DNS lookup is still not in an optimal location because then I'm doing DNS up in the cloud and I'm getting 300 millisecond latency. Not good. So this is where we have a lot of engineering work to do. What we'd like to do is say, okay, then how can we push that cloud into your network? Figure out some way around that. So this is future DNS is not over. DNS is not a protocol that's done yet. Go ahead next. Go ahead next. Right? Finish up. So what we're going to do now is shift over now. So this gives you some thinking on the DNS part. Now we're going to start looking at some of the data you have available as AKAMAI partners with the caches in your network. And then we'll talk about how we can then troubleshoot around some of that and optimize with this parameter called EDNS0, so you guys know how EDNS is called. So, I'll flip over to buttons.
Everyone. Okay, so first of all, are you all connected to APJII direct or you have? Does anyone have their own AKAMAI setup? Anyone else? So that's it. Just to have your own setup. Okay. So we have a folder. Not use that much by the operator. It's a very how to send reports to the management, right? And it gives a lot of analytics, like what Barry already mentioned, that AKAMAI is continuously collecting data. It's collecting data of users who are actually accessing our customer content, right? All First of all, if you do not have you do not have access to the network portal, reach out to us. So have our money. So please reach out after this meeting and I'll just set up the portal. You will actually get a default username and password. The username will be your email ID, password is what I'll set for you, and you will be able to use the portal. What is available on the portal is actually the AKAMAI traffic of the partners, as well as if you have a PNI, if you have a private network interface with maybe at RP or at Puri in Singapore, you actually get details of the traffic that is being passed to that particular interface. Alright, so this is the first landing page as soon as you log into the portal. You actually get the main drop down on the monitor. So on the monitor you can actually see different things with it. AKAMAI cursor actually gives you traffic statistics. The traffic statistics served to you from your particular AKAMAI. You also have the end users out there on the right hand side. That actually gives you a lot of analytics of the different things that we monitor out of your network. So it will actually tell you about the DNS response time. It will actually tell you about the page load time, the time for the first byte. Right? A lot of analytics regarding your network is actually from there. And as you will see later, 3-4 slides down, we are actually trying to reduce the distance between the 95th percentile and the mean traffic. Right? Gary already spoke about the alien data. So what we try to do is reduce the difference between both of these. Okay, so for the network traffic, as soon as you go on the monitor and go to the tab of network traffic, you will actually see traffic that is related to your particular network. Now, this is one of the operators without naming them, and sort of maybe actually it's a big operator out there. But this is actually what you see. So there's a question mark right both sides, inbound and outbound. This will actually give the meaning of what this particular page. So what's the meaning of this particular traffic, right? So it's a very detailed and it's a very detailed list out there, but it's trying to tell you what exactly the traffic you are looking at. What you can also do is you can actually select if there are different points of presence in your network, right? You have one at maybe Jakarta, Surabaya, Batam. You can individually click on each particular road and check the traffic status, check the in-person out traffic, and several more which will actually go through in the next slide. The cluster traffic will again I'm actually second graph right now. So what is actually showing is the health of your network. So as long as the blue line, the blue graph is above 75-80%, that means your network, the traffic that is served to you from your AKAMAI node is healthy. Okay, this is very interesting because this will actually tell you about the number of users at any point of time in a day who are accessing AKAMAI content. So the usage out here is unlike the Google. The difference in AKAMAI traffic is that AKAMAI traffic is all customer event related. Right? So if you see that on the 24th of July, there was an event of our customer, because of which utilization was quite high compared to an everyday average. Right? So the same thing that you see on the 30th of June, right? The utilization of the number of requests coming in for AKAMAI content was much higher, just because it was an event on our customer. So one other thing which is also visible is the state of or the health of your network, as well as the health of the servers in your network. Now, in the AKAMAI network, we always try and overbuild, right? Just because if there are a couple of servers that go down, the remaining servers are still able to right? So you may see red line always suggest that could be around 10 to 12%. we just covered AKAMAI cluster. What we are actually looking at is now the end user, right? The end user or the performance that we get from the end user. Everything to your network. So how your users access AKAMAI content and what is the benefits that you're trying to store and how we are doing it. Very important that the browser needs a particular device, maybe a handheld device or your computer or your laptop at home. That is actually sending information to our server, right? Collecting information, taking our customer. And this is how we actually take the big data and push it out in for it. All right. The first performance, the first analytics or issue of the DNS pickup time. It was very well put up in one of the slides. Very well presented. Actually show you the first part where we had 23 seconds and 500 milliseconds. That was very mentioned. This is one of our partners, and you see the black line and the blue line below is actually the median, right? We expect that that gap will actually narrow down over time just because the performance gets much better. Unfortunately, out here, this particular partner scaled rapidly from 2015, and he had some issues in his DNS because of which you are not able to see that the gap between the black line and the red line, the blue line is still at the same shape because it still has some issues. The better the DNS performance gets, I mean that the gap is essential for AKAMAI and the partners. Like more content is being served in a better way from the network. Okay, again, the time to first byte, the same thing, there's a brief description of what exactly it is. We go to the question mark, right side, the time to first byte, then the time the first byte of the response from your AKAMAI server. If your AKAMAI server is not able to communicate, not have AKAMAI server. The page load time, page more exactly. Page load time doesn't need explanation. The page is fully loaded. And again, this is a third operator that has been on prior to 2015, he was not on AKAMAI. After 2015, when we started having a presence in this particular operator, the blue line and the black line. Again, the round trip time, one of the fine analytics that are actually shown on our again, we are always looking at reducing the gap between the blue line and the red line. So this is what I have over here. Guys are not accessing the computer, so we just suggest that I have reset your password and you're able to and everything can then be exported and thank you.
What we're going to try to do is cover the next two sentences real quick, so then we can have a break at the end and everybody socialize. So close up. So, are you well? So you got as we mentioned before, DNS is important. We're measuring it so you can access. Anybody here who has AKAMAI nodes in their network, right? You can access the network portal. But what if you have something else? What if you have Google? What if you have Facebook? What if you have Netflix?